you have a wire. Okay, so you have a wire of uniform cross-sectional area. Let its length be L. So now let its length be L and it has a uniform cross-sectional area A. Now for this wire, the length of the wire is changed. The length of the wire is doubled. The length of the wire now becomes 2L. So here the length is 2L and area of cross-section now becomes A dash. So you have to find out this wire has some resistance R. What will be the resistance of this wire? You have to find the resistance of this wire R dash. Okay. So come on, solve it quickly and tell the answer. If you know the answer, you can tell it directly. So anyone knows the answer? Be quick in your answers. Anyone got the answer? This is your example 9 in the first question. Okay. Medha Ansini, have you got the answer?
Sir, I can't solve it right now, but I think it will become double because the length is double and the area of cross section is half, probably because it's directly. I
So
mean,
if
R is
length
directly
is,
proportional to L.
yeah, you are going correct. Just do calculation still again. So the length has doubled, so resistance will become double, and area will also reduce to half. So if area reduces to half, the resistance will still become double, and double of double is 4 times.
Okay.
Okay, so we have our new resistance R dash will be given by 4 times of R. Okay, so however you can solve it orally, but still it is my advice, you go it by the proper method. Okay, so by the proper method, write out the expression for R. Some students, they are perfect in doing them orally, but most of you will fall with errors. So it's my advice that you go by solution like this. Here you write the expression for R, that will be equals to rho L by A. Here you write the expression for R dash, that will be equal to rho times of 2L divided by A by 2. So area A dash will now become A by 2. If length will be doubled, then area will become half. If length will be tripled, then area will become A by 3. If length becomes half, then area will be doubled. Okay. So
Sir,
this
L
is from the
directly
conversion of shape.
Sir,
Yes.
L is inversely proportional to A.
L is inversely proportional to A. Yes. This is not inversely proportional. It is inversely proportional, but do not need to remember it, as you can get it from the conversion of shape. Okay. From the conversion of shape, you know that total volume should remain the constant.
Yes,
Okay.
sir.
And volume is given by area times length.
Yes.
Okay. So if this is the initial volume, so final volume we get here, which will be 2L multiplied by the new area A dash, and hence you can get your new area A dash will be equal to A by 2.
Okay, sir. Okay.
Okay. So either way, either if you are good at mathematics, you go like this, or you remember it's inversely proportional. So you get here. Now this 2 will move to the numerator. How it moves, see. Many students find it still difficult. So rho, you write here 2L and divided by A by 2. So this has to be divided by A by 2. Once you convert this divide to multiply, so see you get rho 2L over A, and this 2 will be on the top. 2 by A. Converting this divide to multiply. Okay. So you get 4. You have rho 4L by A. Okay. And rho L by A is R. So you get here 4 times of R. So our new resistance will be 4 times of the original resistance. Okay. Any note? I don't want any doubts. So is there any doubt in this question?
No, sir.
Okay. Now the next one, a copper wire has a diameter of 0.5 mm. So let's solve this question, and I want you all to get correct answer. So mainly this question is given to check your calculating power. Okay. So a copper wire has a diameter given by 0.5 mm and resistivity of 1.6 into 10 to the power minus 6. So it will have resistivity as 1.6 multiplied 10 to the power minus 6 ohm meter. And how much of this wire would be required to make a 10 ohm coil? So the resistance is given as 10 ohm
Sir,
and you have, yes,
sir, it is given as ohm centimeter in the
mm,
question.
okay, resistivity, okay,
Resistivity, yes, sir.
okay, resistivity is ohm centimeter. Never mind, write it as ohm centimeter. Okay, write it ohm centimeter. Okay, so now you have to find out the length of the wire. You have to find out the length. So here, either you convert everything to meter or you convert everything to centimeter. Okay, so the standard is we should always follow the standard, that is you have to convert it into meter. So first of all, you have the diameter. Convert this diameter to meter. This will be 0.5 multiply 10 to the power minus 3 meter. Then again make it standard. It will be 5 into 10 to the power minus 4 meter. But this is diameter. Now radius will be half of it. So radius will be 2.5 times 10 to the power minus 4 meter. So everyone is getting the answer. 2.5 into 10 to the power minus 4.
Yes, sir.
Okay. So this is radius. You obtain the diameter, you obtain the radius. Then see, resistivity is given as ohm centimeter. You have to convert it to meter. This is 1.6 into 10 to the power minus 6 ohm, and it is ohm multiply centimeter. So you just need to convert the centimeter to meter. So this will be ohm multiply 10 to the power minus 2 meter. As 1 centimeter is equivalent to 10 to the power minus 2 meter. Okay. So you get here 1.6 into 10 to the power minus 8 ohm meter. Now it's correct in the, now see everything is now in the SI format. You have radius in the SI system, you have resistivity in the SI system, you have resistance in the SI system, and now you want to find out the length. So find out the length, find the value of length now. Solve it and get the value of length. Okay, so anyone got the answer? Amatur Rahman?
Yes, sir. Just give me 1 minute, sir. I'm calculating.
Okay. Then Vedika, Srilasya, everyone is keeping the camera off, and I don't know what you are doing. If you keep the camera on, then I'll come to know what you are doing. Are you getting the answers? Srilasya, K. Subha Charvik, Shravani, K. Subha Charvik.
Yes,
Are you able to obtain the answers?
I came just a few minutes before.
Okay, so solve the answer then.
Okay.
Okay, so let me check the answers now. Who all have obtained the answer? Okay, I got one of the answer from one people. Okay, someone is given the answer. Medhansini has given one of the answers. Okay, now I'm also solving, and let's see if I calculate first or you calculate first. Okay, so you have to find out R equals rho L by A. R is given, and R times of A divided by rho will be equals to the length. R we know as 10, so 10 times of area. Area will be pi r square, 3.14 times of r square, which is 2.5 into 10 to the power minus 4 whole square, equals to L divided by resistivity, and resistivity is 1.6 into 10 to the power minus 8. So, in the next step, you have 3.31.4, or let's say 314 multiply 6.25 multiply 10 to the power minus 8 divided by 16 multiply 10 to the power minus 8. So 10 to the power minus 8 vanishes, and now you just need to multiply and divide. So multiply 314 into 625 divide by 16.
Sir, we can cancel 314 and 16, no sir, 157 and 8.
Okay, so will it cancel completely?
No.
So there is no need. Then you just simply multiply and divide. Okay, just multiply 314 with 625.
Sir, it's
Multiply
31.4, right? 314 only.
that's multiplied with 10, so it becomes 31.4. Then remove the decimal from the denominator, it becomes 314, right?
Okay, okay, sir.
So you get 314 times of 6.25. Just multiply them. You will get 1962.5 and divide it by 16.
So I didn't understand how did you get the area as 3.4 into?
Pi r squared.
Yes, sir. Okay.
Okay. So this is pi, and r is 2.5 into 10 to the power minus 4. So you are getting 122 meter approximately.
Yes, sir,
So
122.6.
2.4 into 10 to power of minus 4, how did you get, sir?
Which one? 2.4.
Yeah, 2.5, sorry.
So this is the diameter. 5 into 10 to the
Yes.
power minus 4, that's the diameter. And I think you are using diameter only for calculating the area.
Yes, sir, we can use it, right?
No, you have to use the radius. From the diameter, obtain the radius.
Okay.
Okay. Otherwise, whatever answer you have obtained, divide that answer by 4. Then only you will get the answer. Okay. So let's see the next one. Everyone got the answer? Vedika, did you got the answer?
Yes.
Okay. So here, next question we have the circuit diagram. See. So here you have the question. Now can you tell the answer? Redraw the circuit. See, if in figure 3.14 A and B, R1 is given as 10 ohm and R2 as 40 ohm. So you have R1 10, R2 40, then R3 30 and R4 20. Now R5 60. So we have R5 which is 60 ohm and a 12 volt battery. The voltage of the battery is 12 volt. So this is your 12 volt battery. Then is connected to the arrangement. Calculate the total resistance and the total current flowing in the circuit. So find out the total resistance and total current. Okay, Shravani gave you the answer. Shravani has given the answer. We'll check it. For the first one, it's 25. And what is for the second one?
Sir,
Also
I'm
do for
trying to
this.
think.
Okay. So Shravani, your answer is correct. You also have to find out the current. You did not send the answer for current.
Current for both of them.
Yeah, for the first also, second also, both of them you have to find out. You have to find the total current. Okay. What's the current for the first one? I will ask the answer from Amatur Rahman. Amatur Rahman, did you send the answer? No.
Sir, I got it, but can I tell you now?
Okay. Can you tell the answer for the first one?
Sir, total resistance is 25 and
Yeah.
current I got 0.48.
Okay. Total current will be 0. What do you get? 12 over 25.
Yes, sir, 12 by 25.
Okay. So 12 by 25 is 0.048 or 0.48.
Yes, sir.
Okay. 0.48 ampere, right? For the second one, okay. Anyone got the answer for second one? Srilasya?
You're doing, sir.
The current is not 0.43, I think it's 0.48. Yes, Ravani, you can check.
Yes, sir.
So everyone, I think, got the correct one. So see, now I think it's time I should tell the answer for it to everyone. Are I'm get Vedika.
Yes, sir.
Are you able to get the answer?
Yes, sir.
Okay. So for the second one, you will have your equivalent resistance considering R1 and R2 in parallel. So you have your 10 and 40 in parallel, and the equivalent resistance you will get here, R equivalent will be equal to R1 R2 over R1 plus R2. So R1 R2 is 400 divided by 50. That's 8 ohm for this upper part. And similarly, you need to find out for the lower part. For the lower part, your 1 over R will, will be equals to 1 over 60 plus 1 over its R3 is 30 plus R4, that's 20. 1 over 20. So LCM comes out to be 60. You get here 1 plus 2 plus 3. So 1 over R is equals to 6 over 60, and hence R is 60 ohm. So the outcome out R will be 10 ohm, not 60. So here you get 10 and here we get 8. Hence the equivalent resistance becomes 18 ohm. Here we get R equivalent as 18 ohm for the second resistance. So I think someone had given the wrong answer. Yeah, Shravani.
Yes, sir. I
Check.
forgot to add it.
Okay, you forgot to add them. Fine. Anyone? Okay. So you got the resistance. In the same way, you will find the current and hence the answer.
The total resistance, right? Should we add it 8 plus 10 or 1 by 8 plus 1 by 10?
See, they are in series. Is there any current dividation?
No, sir.
No. So it's the series combination.
So it will be 8 plus 10.
Yeah, it will be 8 plus 10, that's 18 ohm.
Okay.
So similarly, we see the next one. Okay. Here you have a few of the questions. You can see. What is the importance of rheostat in a circuit? So what role does the rheostat perform? Srirasya, what role does the rheostat perform? Yeah, Kesuva Charvik. What role does a rheostat perform in a circuit? Now I think is K. Subha Charvik shall answer. K. Subha Charvik. Yes, K. Subha Charvik, can you answer? Importance of rheostat in a circuit. What is the importance of rheostat in a circuit? Uh, Let me ask someone else then. K. Subha Charvik, are you there? Amatur Rahman? Amatur Rahman?
Yes, sir.
Okay. So what is the importance of rheostat in a circuit? Why do we use a rheostat?
Sir, it's a device used to regulate the current. Sorry, resistance.
Potential. Yeah, it's a device. You can say it is used to regulate potential difference, or it is used as a potential divider, or
Hmm.
it is used as a variable resistance. Graphically represents the VI characteristics, that is relation of a nichrome wire. So you just have to draw a VI graph. Okay. And we know that the shape of the VI graph is linear. So we get a linear graph. Then what do you mean by resistor? What do you mean by resistor?
It's a device that produces resistance.
Just 1 minute. Okay. It is an resistor is an electrical device which offers a high resistance to the flow of current. Then question number 4, a 4 ohm resistance wire is doubled on it. Find its new resistance. So what will be the new resistance?
Sir, is it 16?
No, again check it once more. A 4 ohm resistance wire is doubled on it. Doubled on it means? See, it is
Sir, it will
doubled
be
on.
4 times the resistor. Sorry.
Yeah.
Oh,
Sir,
So
is it
this is a wire. It has the resistance 4 ohm. Then it is doubled on it. Okay. So doubled on it means now it's like this. And the same part again over here. So like this. Okay. So now what will be the new resistance? Here it has the resistance R equals to 4 ohm.
sir? If it's doubled, length will be 2L and area will be A by 2, right?
Length will be 2L or L by 2. It is
Sir,
doubled on it.
area will be, area is doubled, so the length will be decreased. So it's
Yeah,
probably 4 by uh, the resistance, so maybe 1.
yeah, the answer is 1. Okay, a 4 ohm resistance wire is doubled on it. You will have the resistance of 1 ohm. Then what will be the resistivity of the wire in the above case?
sir, can you explain how L by 2, sir? If it's doubled,
Doubled on it by folding it. So from here, it is folded like this. Okay, so this portion, half the portion, this is your L by 2, this is L by 2. Okay, so half of the portion is folded above it. So now you can see the total length of the wire. The total length of the wire is L only, L by 2.
oh,
The
okay.
total length is L by 2, and now its area of cross section has increased to 2 times.
Okay, sir.
Okay. And what will be the resistivity of the wire in the above case if original resistivity was rho? So originally the resistivity was rho. What will be its new resistivity?
Same, sir, it will be rho. because
Yeah,
it's
it will be same. No changes in resistivity, as resistance does not depend on the geometry of the wire. Then see question 6. Question 6. A heater draws 5 ampere current from the source. How much current will it draw from a potential difference across its two ends is double? So how much current will it draw if the potential difference is doubled? Vedika? Yes, Vedika, what will be the answer? A heater draws 5 ampere current from the source. How much current will it draw if the potential difference across its end is doubled?
Sir, I'm
Yes.
sir, please, after this, can you once solve fourth one? Like with steps.
Fourth one.
Yes, sir, I'm not getting one as the answer.
Okay. So what happens to the area?
Area will be A by 2, right, sir? Sorry,
No,
2A.
area will be 2a. And now you can solve, you get the answer then.
I'm getting 1 by 4, sir.
1 by 4.
Yes,
Okay.
L,
So
L
what
by,
it will be r by 4, right?
yeah, like that only, R by 4, because 1 by 4 and then into,
Yeah, so that's correct. R by 4, and you have the original resistance as 4 ohm. See? The original resistance is 4 ohm. So its new resistance will be 1 ohm.
oh, okay.
Now see question number 6. See question number 6. A heater draws 5 ampere current from the source. How much current will it draw if the potential difference across its ends is doubled? So as we know that the current is directly proportional to the potential difference, and if the potential difference is doubled, so what will happen to current? Current will also get double. Current will also become double of it.
Sir, can you repeat? I was unable to hear you.
Which one?
The sixth one, sir.
Sixth one. The potential difference is directly proportional to current. We know V is directly proportional to I, or I is directly proportional to V.
Yes, sir.
Okay. So initially it has a current of 5 ampere. Then it says how much current will flow, will it draw if potential difference is doubled. So if you double the potential difference, the current will also become double.
Okay. Yes, sir.
So the new current will become 10 times.
Yes, sir.
Okay. So it will be 10 times. Now let us draw these two questions. You have these two circuits and try to solve them one by one. So we try to solve them one by one. Question 7. You have to calculate the equivalent resistance in each of the following. Okay, so I'm expecting answers from you people. For the first one, K. Subha Charvik is not responding at all. Maybe he's having some issue. K. Subha Charvik, Vedikas.
yes, sir.
So obtain the answers.
Yes, sir.
Okay, I got one of the answer. Shravani gave the answer. See, for the first one, you have to first find out their series. So series of 5 and 4 will be 9. So this will produce a resistance R of 9 ohm together. And a parallel of 2 and 2 will create you a resultant of 1 ohm. This is 1 ohm. And if you find out the total, see both of them, they are now connected in series. So you can find their total, which will be 9 plus 2, 9 plus 1, that is 10 ohm. So for the first circuit, total resistance is 10 ohm. You can find the total current as 10 over 10, that is V by I. This is 1 ohm, 1 ampere. Now for the second diagram, see for the second diagram, 3 ohm, 3 ohm, 6 ohm. You have a voltmeter drawn over here. Okay, anyone got the answer for this? Okay. Yes, anyone? You can redraw the circuit if you want.
Yes, sir, the resistance is
Hmm.
3.
The resistance is 3. So how did you get 3?
Sir, first I took the first two ones which had the resistance 3, and then I put them in series. And when I put those two in series, they'll be parallel to the other ones, and I
Okay.
solved it.
Okay, so it's easy, you can do this. All the questions can be done now. Just let me see now, coming to the topic. Yes, in the last class, we were discussing about life cycle. And in that life cycle, we were discussing mainly about,
So once can you tell the last one answer?
okay, see the last one answer for this. For this, you want the answer?
Yes.
So, first of all, you will take the 3 ohm and 3 ohm in series. Okay, so 3 ohm and 3 ohm, they are in series, forming together 6 ohm. Then the 6 ohm and the 6 ohm, they are in parallel, forming together as 3 ohm. Got it?
Yes, sir.
Okay. So now let's continue with that chapter, control and coordination. So in that we had done about the circulatory system in human beings. We had done the circulatory system, and I had also given you some points about the limb. Okay. Do write those points about limbs which were given over there in notes. Until then, if anyone is having doubts in any of the problems, over here, any of the any of the topics that we have done. For example, up to now we have done about uh, see what all things we have done. Up to now we have done here nutrition, then we have done respiration, then we have done circulation, and now we have to do excretion.
Sir, we didn't exactly complete circulation.
No, circulation was completed. I don't think anything is left out after that.
Sir, we
Uh,
have to see like heart in different amphibians, fishes, and all that.
we have, okay, so that is what we have to see. Just 1 second. Okay, one second, I'm showing. Okay, so you have the life process, and we were here. Vedika, what is ADP and what is ATP? Vedika? Okay, let's see now. The heart and the blood capillaries. See. So I told you almost how to draw the heart, okay, how to draw the structure of heart. So first of all, the blood from all parts of the body, it fills into the right atrium. And this blood which fills into the right atrium is called as the deoxygenated blood. It is the deoxygenated blood which fills the right atrium. The right atrium has one valve at the bottom. This is called as auriculoventricular valve. That means the valve between auricles and the ventricles. So this is an auriculoventricular valve. When the valve is closed, the auricles start filling with the blood. Once the blood is filled up in the auricles, so then the auriculoventricular valve, that means this valve, it opens up. So the name of this valve is auriculoventricular valve. It opens up and hence blood starts filling up the ventricles. So once the ventricles are filling up, so an impulse originates from this area, and this area is called as the sinoatrial node. Okay. So from this region of the heart, which we call as the SA node, so from the SA node, you have the starting of the electrical impulse, which gives rise to the contraction of the heart. Okay, so heart muscles start contracting. So the heart muscles contract, and once the heart muscles start contracting, so the auriculoventricular valve closes and the pressure increases inside the heart. Okay. So currently, when the pressure is increasing, all the valves of the heart are closed. Yeah. Okay. So Amatur Rahman, is there any problem? Amatur Rahman, is there any problem? Okay, fine. Vedika.
Yes, sir.
So see what happens, the auriculoventricular valve opens up and then the heart muscles contract. When the heart muscles contract, the pressure builds, and when the pressure reaches its limit, it is then the semilunar valves of the auricles and the ventricles and the pulmonary artery, it opens up, pressing the blood with high pressure into the pulmonary artery. So this from here the blood goes to the pulmonary artery. In the pulmonary artery over there is exchange of gases so that the blood becomes oxygenated. Once the blood becomes oxygenated in the pulmonary artery, so it is brought back to the heart through the again vena cava. Now the vena cava are of two. One is a superior vena cava, the other one is inferior vena cava. Superior vena cava, it collects the blood from the upper parts of the body. And inferior vena cava, it collects the blood from the lower part. Okay. Now, can you name the artery which supplies blood to the heart vessels? The artery which supplies blood to the heart vessels.
Pulmonary artery.
No, it's not pulmonary, it's a coronary artery. So coronary artery is the branch of aorta which supplies blood to the coronary artery supplies the blood to the heart muscles. That's the next one. So this thing we had done. Lymph also we have done. You see, these are the different circulatory paths. This is the circulatory path in fishes. So as we know that the heart of the fish is two-chambered. So you can see here, there are two-chambered heart present in the fishes. But in amphibians, you observe here three-chambered heart. Amphibians have three-chambered heart. All the amphibians means animals we can fly off. Those are amphibians. Then last comes the mammals. So all the mammals, they have a they have four-chambered heart. So this is the main difference. Fishes will have two-chambered heart. All the birds will have three-chambered heart, and mammals will have four-chambered heart. You see transportation in plants. So plants mainly perform two types of transportation, that is transportation of water and transportation of food. So at this stage, can you define sap? What is sap? Yes, what is sap? Sap is the fluid mixture containing water and nutrients that is necessary for the plant. Okay, students, so we'll see in the next class. We have to start with phloem and then we can move on to excretion, which is the last topic of this chapter. Okay. I'll also like you if you can go through these notes so that you'll be able to remember all this. Okay. Bye everyone. Good night. Okay, so good night. See you again in
Thank
the
you,
next
sir.
class.